Hey guys, welcome back to the Quick Maths channel. This will be the MRSM paper 2, the MRSM 2020 paper 2. So the way that I'll be doing these questions is I'll be doing them systematically from 1 to 15. However, for the the questions that require drawing of the graph, I will not be actually drawing the graph, but I will be covering the method and how to basically solve the question. The solutions to the questions are actually in the answer sheet, so you can refer to the answer sheet. If you guys would want to see how I would draw the graph, then do let me know in the comments. Then I can make a video exclusively to show you how I would draw the graph. But aside from that, I will be explaining generally how to solve the question, and we'll be using the answers to sort of guide you guys towards the questions for the questions that require graph. Right, so without further ado, let's get started. So for question number 1, prove that sec square minus tan square a over tan a plus cot k equals to sine 2a over 2. So we just basically just get down the question. So sec square a minus tangent square a over tangent a plus cotangent a equals to sine 2a over 2. So from here, the way that we solve this is we usually take the side that's a bit more complicated because it's actually easier to work with, ironically enough. So we will be taking this side of the equation. This is the left hand side of the equation, so I will be calling it the LHS. So LHS equals to sec square a minus tangent square a over tan a plus cotangent a. So from here we have something that we can work with immediately. So we have an identity where 1 plus tangent square a is equals to sec square a, and another identity where we know that tangent x, or tangent a in this case, equals to sine a over cos a, and also cotangent a is just the inverse of that, which is cos a over sine a. So from here we can sub in all of our identities. So we have 1 plus tangent square a minus tangent square a over tan a is sine a over cos a plus cos a over sine a. So for the top part of the fraction, we can cancel these two out, so we are just left with 1. And for the bottom part of the fraction, we can actually multiply them, so to make the denominator the same. So on this side I multiply sine a, and on this side I multiply with cos a. So I'll have sine square a plus cos square a over sine a cos a. So we got a 3-layer fraction. Usually it's a bit easier to see if we don't write it in a 3-layer fraction. We can instead write it like this, because this is the bigger division line. So I can write it as 1 divided by sine square a plus cos square a over sine a cos a. And from here, I will be able to use another identity for this, which is sine square a, oh dear, sine square a plus cos square a equals to 1. So I'll be converting this to 1, and it'll be 1 multiply with, this one flips, so it'll be sine a over cos a over 1. So from here we have just sine a cos a. So sine a cos a is actually related to another trigonometric identity where we know that sine 2a equals to 2 sine a cos a. So we can say that since sine 2a equals to 2 sine a cos a, if we make sine a cos a the subject, it would be sine 2a over 2. Therefore, we have proven the identity, and this is equivalent to the right hand side, and this is proven. Right? So that's how we prove this inequality. This equation. So not enough space to work with here, so I'm just going to erase this. Please pause the video, for those who haven't watched the previous video, if you guys would like to try the question first, you can pause the video, and if you guys want to see the solution or you want to copy down the working, please pause the video. So because I'm just going to go straight into every question, so please take note to pause the video immediately after every question if you would like to copy down the working. So for B1, hence sketch the graph of y equals to 2 secant square a. So now, assuming that you couldn't have done the first part, as in you couldn't have proven the first part, don't worry, you can still use whatever they gave you in the previous question. Alright, so obviously we're not going to sketch a graph like this. This graph is way too complicated. So we're gonna simplify it by writing in the y equals to the sine 2a over 2 substitution. So here we can cancel out. So we have the graph y equals to sine 2a. So they gave us the domain, which is from 0 to 2 pi, essentially just 0 to 360 lah, degrees. So they asked us to sketch the graph. So this is a pretty okay sketch. So whenever they change the number here, now usually 2 is a pretty simple one to remember, but what if they use something like a fraction or like a very weird number? So most students would be confused beyond 2 or numbers that are fractions. So in order to identify or in order to find out how we can actually plot the graph properly, first we start with the identity, right? We know that y equals to sine x, correct? So y equals sine x, the most basic graph is like this, right? And this is 0, this is 90, this is 180, 270, and so forth, 360, right? Now, we will usually take the reference point of 90 degrees. When sine is 90, we know that we get 1. So this is the most basic identity that we can use, this basic angle that we can use to sort of identify where our graph will hit 1 first. So in this case, sine 2a, I can just write down as 2a equals to 90, and I can make a the subject, which is equals to 45 degrees. So I know that my graph's interval is every 45 degrees. So in this way, this graph's interval is every 90 degrees, where it changes its value. So depending on what number they gave me, I can tell what is my interval, right? So assuming that, let's say I give you a graph of sine 3 over 2a, I can very simply just put 3 over 2a equals to 90, and from there I know that a is 60. So my interval is 60, 120, 180, 240, 300, 360, and so on and so forth, right? So this method is actually very useful to find the intervals. So since I know the interval is at 45, therefore I can actually plot my graph. So I'm just going to do a simple sketch here. So here is 45, 90, 135, 225, a bit short, 280, 315, 360. Apologies for the weird curve. Can this draw straight? Oh yeah, I can actually draw a straight line, but it's just a bit thick. Yeah, there, much better. So let me just erase this part. Okay, something new every day. Okay. So from here, I'm just gonna make a really quick sketch. So like this and like this. Okay. So from here we have gotta change back to the pen. Right. So like this. So this is y, this is a, and then I'm just gonna draw simple intervals: 45, 90, 135, 225, 280. 315, and just a little bit longer, I guess, and 370, 360, sorry. Okay, so advisable to use a ruler and then just measure like maybe a cm or half a cm, just to so that when you sketch the graph it looks a bit nice. So we know that sine 2a graph starts from 0, and the first interval 1 is here. So the next interval is here, next interval is here. Oh, sorry. I need to undo this. Next interval is here, next interval is here, 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 and here. So, did I miss anything? Seems like I did. Yes, I did. So 135, yeah, I missed this. Is supposed to be 180 degrees. So I'm just gonna cap this. And just gonna draw a little bit longer. I should just draw like an entire line next time, just to make it a bit easier to work with. So 225, 270, 315, 360. This is A. Okay, so now we have intervals here, 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 and here. So we're just gonna draw a simple sketch. Ooh, terrible, terrible, terrible. Okay lah, not too bad, but can be better. Okay, never mind. So this is a simple sketch. So just let's label the axis, label the origin, and you'll be done. Alright. So part 2, find all the possible number of solutions that satisfy the equation sine 2a equals to k. So when they say possible solutions, it's not the same as the exact number of solutions. Means that because sine 2a equals to k, we know that y equals to sine 2a. Essentially, it means that when they say sine 2a equals to k, they are looking for when y equals to k. So y equals to k basically means it can be any value that is positive or negative, right? So essentially what they're doing here is that they are actually asking us, what if I drew a line here? Oh wow, that's very thick. What if I drew a line here? What if I drew a line here? What if I drew a line here and so on and so forth, right? So they are looking for how many possible solutions. So from the get-go, what we can tell is that there are three crucial points that we can see. We are looking at this. It's supposed to align with the tip, right? Like this. And this is the second one. And then this is one more, which is the third one here. Okay, so why did I highlight these few points precisely? Because they gave an interval from negative k. Let me change here. They gave from negative 1. Oh, this is too light. From negative 1 to 1. So from here, what they are trying to say is that I can move this blue line anywhere between here and here. But these three lines that I highlighted here actually provide us the solution that we need already, right? Why is that? Because from here, just gonna get rid of this. So from here, what we can understand is that we know that at the top here, there's going to be two solutions. So there is one set of solutions where we can say that when y equals to 1, there are two solutions. Or in other words, I should say when k equals to 1, since we are referring to k. So when k equals to anywhere between 1 and 0, we know that the number of solutions is 4 solutions, because there is 1, 2, 3, and 4. And when k is equal to 0, we know there are 5 solutions, because there is 1, 2, 3, 4, 5 solutions. Didn't draw all the way here. So ultimately, we have 3 types of solutions. We don't talk about the one below because we are going to get the same type of answers below as well. So therefore, our possible solutions in this case would be 2 solutions, 4 solutions, and 5 solutions. So this is question 1 done. Right, question 2. So question 2, Ainul bakes a 2 kg cake with the height of 10 cm. She wraps around the side of the cake with a ribbon measuring 57. Find the possible length and width of the cake. So just gonna call this length and call this the width. So from the very beginning, we can make a simple equation because they wrap the ribbon of 57 cm around it. So we can say that L plus W plus L plus W equals to 57 because we are talking about the perimeter here. So it's 2L plus 2W equals to 57. This is equation 1. So she baked a 2 kg cake with a height of 10 cm, and interestingly enough, they gave us the volume. 1 kg is equal to 1000 cm cubed, so I can actually play with the volume. So volume equals to length times width times height. So the volume of the cake is basically 2 times 1000 because it's 2 kg and they gave us 1 kg as 1000. So the length W we don't know. Height we know it's 10. So it's 2000 equals to 10 LW. So I'm just going to make maybe W the subject here. So it will be W equals to 2000 over 10 L. So W equals to 200 over L. So I'm just going to call this equation 2. So I have 2 equations to work with now. So I'm going to say sub 2 into 1. Right? So it will be 2L plus 2W, which is 200 over L, equals to 57. So it will be 2L plus 400 over L equals to 57. I'm going to cross multiply it. So it's 2L squared plus 400 equals to 57L. So 2L squared minus 57L plus 400 equals to 0. And then we can solve this quadratically. So let me just see. Maybe 2, yeah, probably 2 and 400. What is it? Maybe 25. Yeah, 16, 25. Yeah, so something like 2L minus 25. Does this work? L plus 16. No, not plus. It should be minus. Yeah, so something like this, right? Let me just cross check with my calculator. Yeah, yeah, I can get proper values here. So it will be L equals to, alternatively, you can actually use the quadratic formula for this, but just for the sake of time, I'll just omit the quadratic formula from it, because what I'm using is actually the cross method, just without the actual cross method shown. Alright, so actually maybe I should just show the cross method, since in case any of you are wondering how in the world did I get that. So the cross method basically is, I'm just going to draw two lines here, right? And I will have basically two inputs here and two inputs here. So these inputs are basically something multiplied with something to get this result. So in other words, how to get 2L squared, I'll just say one is 2L and one is L. And what multiplied by what is 400. So just now I took 16 and 25. So I actually ordered them on purpose. So I put 25 here and I put 16 here, right? And I put them as negative. So why do I do that? Is because when I draw the cross, right, I'm going to multiply across, so it's 2L times negative 16, which is negative 32L, and this is L times negative 25, which is negative 25L. And when I minus these two numbers together, I get negative 57L. This number should match this number. So if they do match, means that your solution will be here. This and this, which is 2L minus 25 and L minus 16. So I can solve for L, so that means 2L minus 25 equals to 0, L minus 16 equals to 0. So 2L equals to 25, L equals to 12.5, and L equals to 16, right? So I have one set of solutions here. So my other set of solutions is going to come back from here. Maybe I'll just use this equation 2. So I'm just going to sub it back into 2. So it will be when L, we have 2L, so L is 12.5 and the other L is 16. So actually, you notice I'm gonna get back the same solutions, I think. Yeah. So you can take either one of the solutions in this case. So when L equals to 12.5, W equals 16. When L equals to 16, W equals to 12.5 cm. Right? And this is done here. So number 3, diagram 2 shows a square sheet with the sides of 1 meter. So sheet is folded into two equal rectangles, then rectangle folded became a square, and then continues indefinitely. So determine the first rectangle or square that has an area of 0.0001 meter square. So determine whether this is a rectangle or square. So first of all, let's just look for when we are able to reach that. So by looking at the progression, we know that it is automatically geometric because we are working with a R, right? So geometric progressions usually work with times and divide. So from this simple progression, we can see that it's dividing by 2. The pattern is basically just dividing by 2, right? So we know that R is 1 over 2, and we know A is also 1 over 2. So we want to look for when does the area become 0.0001 meter square. So we're going to take Tn less than 0.0001, right? So by following the formula for Tn, the formula for Tn is here. Tn equals to ARn minus 1. So we have ARn minus 1 less than 0.0001. So your A is half, your R is also half, and this is n minus 1. This is 0.0001. So you multiply 2 on both sides to get rid of the half. So this half retains, and this is 0.0002. So we take log 10 on both sides, right? So we take log 10 because whenever we have unknowns as an index or power, we use log because we want to apply the log law where we bring the power forward. So the log law that I'm referring to is this, log AB power C. When you move it like this, you can write it as C log AB, right? So that's why I take log. So it will look as n minus 1 log 10 half less than log 10 0.0002. So I'm going to make n minus 1 the subject. So I'm going to divide it by... So when I divide by log 10 half, log 10 half is basically a negative number if you apply in your calculator. If you put a log that's lesser than 1, so basically log 10 a equals to negative where a is less than 1. So any value in here that's less than 1, the log result automatically becomes negative. So if you divide both sides by this, your symbol is going to change direction to become more than. So it will be log 10 0.0002 over log 10 half. Right? So it is n minus 1 greater than log 0.0002 divided by log 0.5. So it's n minus 1 greater than 12.288. So n is greater than 13.288. Therefore, we know that n is equals to 14. So we know that n equals to 14 in this case, where the first rectangle or square that has this area. Now, when we find this already, we are not done because we still need to identify whether it's a square or rectangle. So a very simple test for this is, first we need to find out what is the area. So we know it's T14. So it's going to be half 14 minus 1. So it's half to the power of 13. So it is actually 1 over 16384. So a simple test is that if we square root this and if we get and if we manage to get a result that is non-decimal or a proper cert, like if we can consider this to be a perfect square, then we can actually consider this to be a square. So when you square root this result, you notice that you will have 16384. So your answer is 1 over 128. Right? So we can consider this a square because it means this is the length of that square. So if you see like this is 1 over 128. This is also 1 over 128. They are the same length, so it's a square. So if you multiply them, you get the same result here. Right? So we know that, therefore, it is a square. It is a square. Right? So this is A done. So moving on to B. So I'm just going to erase the whole thing. So find the total area in meters squares of the rectangle in the series. So we need to create another series where we are working with rectangles. So the very first rectangle is half. The next rectangle is 1 over 8. And the next rectangle after that is 1 over 32. And we can see a pattern here which is divide by 4. So A is half. Our R is 1 over 4 now. And we are going to find the sum to infinity because this is a pattern, a sequence that goes on indefinitely. So we're going to sum it to infinity. So A over 1 minus R is the formula. Half 1 minus 1 over 4. From here we have 1 over 2, 3 over 4. So we have 0.5 divided by 3 over 4. So it's 2 over 3. So this is the total area in the series. So question number 4. We have diagram shows a car skidded due to slippery road. Given the equation of the road modeled by the curve is y equals to 3 over 2x minus 2. So the car skidded in a straight line such that it is a tangent to the curve where with gradient negative 3 over 2. So we have a illustration of the skid for the car. Hope that guy is fine. So if there is a construction cone located at the wayside 1, 3, will the car hit the cone? Justify your answer. So first of all, we need to create the line equation because this is a tangent line, which means that it is a line equation. So they gave the coordinate of the cone, which is possibly on the line. So we need to test whether this coordinate is on this line here. Right? So let's work with getting the line first. So they told us the gradient is negative 3 over 2. So we can say that dy dx equals to negative 3 over 2. Right? So from here, we are going to differentiate this equation so that we can make a relation here. So from here we have oops, sorry. Yeah, there we go. So from here we have y equals to 2x minus 2 to the power of negative 1. So dy over dx equals to, so we're going to apply the power rule here. So it's negative 3, 2x minus 2, this one retains the same. You minus the power by 1, and we are going to differentiate the inside, so it's 2. So the end result is negative 6 over 2x minus 2 square. I just brought it back down for ease of calculation. So we know that dy dx is negative 3 over 2, so I'm going to make a relation for it. So negative 3 over 2 equals to negative 6 2x minus 2 square, and I'm going to cross multiply. So when I cross multiply, I'm going to get, just going to write it here, negative 3 times 2. Oh wait, there's no 2 there. My mistake. There's no 2 here. Okay, there is a 2 here. 2x minus 2. Okay. So from here, we're going to cross multiply. So it's going to be negative 3, 2x minus 2 square equals to negative 6 times 2. So I have divide by negative 3 on both sides. So it is 2x minus 2 square equals to negative 12 divided negative 3 is 4. So we're going to expand this bracket. 4x square minus 8x plus 4 equals to 4. 4x, we're going to factorize it, minus 2 equals to 0. And it's 4x equals to 0, and x minus 2 equals 0, x is equals to 0, x is equals to 2. So we're going to take this value here, x equals to 2. So we take x equals to 2 because if we take x equals to 0, our equation is going to become undefined. So you notice that if we sub it inside here, y equals to 3 over 2x minus 2, if I sub in x equals 0 here, actually no, it's not going to be undefined. It's going to be, I'm going to get another coordinate anyway. But we can just stick with either one of these lah. Yeah, basically we can use any of these to sort of create our equation. So I'm just going to choose one of them. So I'll just stick with x equals to 2. So I'm just going to continue here. So I'm going to erase this part here. Right. So when you have x equals to 2, means that we have one of the coordinates. So we have x equals to 2 here. So I want to find the other coordinate, which is which I can sub into the curve equation here. So we have y equals to 3 over 2 times 2 minus 2, right? Because what happens here is that basically the curve looks something like this. The line probably cuts somewhere like this, possibly, right? So the 0 and 2 lie somewhere around here, right? We don't know which one we're referring to, but it is still a point on the line. That's why we can substitute it inside. So it's y equals to 3 over 4 minus 2, and it's equals to 3 over 2. Right? So this is the y coordinate. So I have a coordinate of this point here, which is 2, 3 over 2. Right? So using this coordinate that I got, I'm going to create a line equation. So y equals to mx plus c. Right? And I already know what's the gradient of the tangent, which is negative 3 over 2. So it's y equals to negative 3 over 2x plus c. And I can sub in the x and y's so that I can find the y-intercept, which is c. So it will be 3 over 2 equals to negative 3 over 2 times 2 plus c. 3 over 2 equals to negative 3 plus c. And 3 over 2 plus 3 equals to c. c is, in this case, 9 over 2. Right? So now I've created the line equation. So I got to test it out now. So since I have y equals to negative 3 over 2x plus 9 over 2. Now I gotta test whether the cone is in the line. So I'm gonna say at x equals to 1, you're just gonna sub in one of the coordinates. So y equals to negative 3 over 2 times 1 plus 9 over 2. So y equals to negative 3 over 2 plus 9 over 2. And we can see that y is equals to 6 over 2, which is equal to 3. Therefore, the cone will be hit as it is on the line in which the car skids. Right? So this is justified. So question 5, calculate the mean for, table 1 shows a set of data for bleep tests recorded by Raman. Unfortunately, he splashed some ink on the data. He literally poured the ink, I would say, not really splashed. So calculate the mean of the data for omega group. So they provided some values here. So they have sigma. Sigma is basically standard deviation. So the standard deviation formula that we know is standard deviation is equal to the square root of the summation of x square over n minus the mean square. I think I'm blocking here, so I'm just going to write it below here. Summation x square over n minus mean square. So from here, we have sigma, which is equals to, we have a few values to work with. So we have square root of summation x square. So it's 260. So I know how many people are there. There's 1, 2, 3, 4, 5. And I don't know the mean. but I know the standard deviation. So it's 4 equals to square root of 260 divided by 5 is 52 minus mean square. So to get rid of the square root, I'll square on both sides. So it's 16 equals to 52 minus mean square. 16 minus 52 equals to negative mean square. So just gonna get it positive. So it's mean square equals to 36 and mean is equals to 6. So this is the mean for the omega group. So B, given that the mean of the omega and gamma group are the same, find the variance of the whole data combined. So we would like to combine the variances. So in order to combine variances, we still need to know some parts of the data here, which is still unknown to us. But we know that the mean here is 6 as well. Mean here is 6. So from here, we can work with the standard deviation of the gamma group. So the standard deviation of gamma group is 5. So we can use the formula again. Square root of summation x square over n minus mean square equals to 5. And I don't know the summation x square, but I know that they have 4 people here. 1, 2, 3, 4. Minus mean is 6 square root equals to 5. So I can make summation x square as my subject. So from here we have square on both sides. So it's summation x square over 4 minus 36 equals to 25. Summation x square over 4 equals to 25 plus 36, 61. And summation x square is equals to 244. Right. So now I know the summation x squares already. So I can actually calculate, I can actually start working on the combined variance. Now, since the means are combined, logically, if their means are the same, means even if you combine the data, the mean is still the same. But in order to sort of show this, we have to write it as summation x over n equals to the mean, right? So this is for the omega group. So we actually don't know the summation of x, which is the adding up of all of the scores here, which is covered up in paint. I was gonna say blood, but it's paint. So n is 5 and the mean is 6. So the summation of x is in this case 30. So we know that this is 30 here. And in this case, for the gamma group, the formula is summation x over n equals to mean. Summation of x is unknown. N is 4 and the mean is still 6. So the summation of x is equals to 24. So here is going to be 24. So since we know this already, I'm just going to get rid of this. So I can count the total mean. So total mean is basically summation of x for the omega group plus the summation of x for the gamma group over the total number in the omega group and the total number in the gamma group. So it is actually 30 plus 24 over, this is 5 plus 4. And you're going to notice that we're still going to get 6, right? But we still need to prove it, otherwise they think we hen tam. So from here, now we can find the combined variance. So the combined variance, so it's sigma square this time. So sigma square variance is just that we don't have the square root symbol there. So summation x square over n minus mean square. So the summation x squares we need to add together. So it's 260 plus 244. And now the n is going to be 9 because there are 9 students now. So minus the mean is still 6. So it is 504 over 9 minus 36. And that is 20. So this is our variance. Right, so 6a, solution skill drawing is not accepted. I feel like he might have drawn on this. Yeah, someone might have drawn on this paper. I don't think the line is given so obvious here. So find the equation of a straight line which passes through point T and perpendicular to the line RS. So they gave us a clue perpendicular to line RS, so I can actually connect R and S together. And I can find the gradient of RS first. So that is 9 minus 3 over 2 minus 4. So for those who are not sure about the formula, gradient is y2 minus y1 over x2 minus x1, right, between 2 points. So it is 6 over negative 2, which is negative 3. So if I want to find the gradient of the line T, I can make a relation where m1, m2 is equal to negative 1. This is for perpendicular lines, right? This is the formula for gradient for the perpendicular lines. So I can do the same here, where I say mt times MRS equals to -1, and I know what is MRS, which is -3. So I can make mt the subject by dividing by -3, so I'll get as 1/3 positive. So the equation of t, or line of I would say t lah, right, to make it simple, is y equals to 1/3x plus c. So I can sub in the value for x, which is -3, and y, which is 4 from t. So 4 equals to 1/3, oh dear, 1/3 times -3 plus c. So 4 equals to -1 plus c, and c is equals to 5. Therefore, my equation will be y equals to 1/3x plus 5. So this is my answer for A. This is the line y equals to, this is the line T that is perpendicular to the straight line RS. So I found this one. This is done. I guess that's why they drew it like that lah. Okay, so part 2, they told us that point P moves such that its distance is always 5 units from the midpoint RS. So find the equation of the locus P. So P always 5 units. So whenever we see the word always 5 units, automatically we know it's a circle. Why do we say that? It's because in order for you to be always 5 units from something, you basically need to be circling it so that your radius is 5 all the time. So we know that it is a circle. So the point that we are referring to is, the midpoint of RS. So to find the midpoint of RS, we are gonna use the formula for midpoint. So midpoint formula is basically x1 plus x2 over 2, y1 plus y2 over 2, and these are the coordinates. So from here it is 2 plus 4 over 2, 9 plus 3 over 2, and that is 6 over 2 is 3, 12 over 2 is 6. Right? So if I were to illustrate the locus, it would just be this point here is 3, 6. I'm just going to draw a simple circle, and the point P is constantly moving, so I'm going to call this xy. So the distance here is always 5. So just take note that this distance is the radius, and this radius can be calculated using Pythagoras theorem, right? So since we can use Pythagoras theorem for this, I can find the x distance and y distance. So if I were to illustrate it like this is 5. This is the midpoint, which is 3, 6, and this is P, which is xy. Why I can use Pythagoras theorem is because, you see, I can create one like this. So this is actually x minus 3 because of x distance, and y distance, this is actually y minus 6. So by using Pythagoras theorem, I have square root of x minus 3 square plus y minus 6 square equals to 5. Equals to 5, yeah. So I'm going to square on both sides to get rid of the square root. So at the same time, I'm going to expand this. So it'll be x squared minus 6x plus 9 plus y squared minus 12y plus 36 equals to 25. So it will be x squared plus y squared minus 6x minus 12y plus 20 equals to 0. And this is the locus, right? So part 2 hence show that the locus P does not intersect the x-axis. So in order for you not to intersect the x-axis, generally it means that you don't have any roots, right? So when we talk about no roots, we refer to the discriminant where b squared minus 4ac is less than 0. So we need to play with the discriminant, we need to prove that it's less than 0. So in order to do that, since we know it's an x-intersect, so we are going to just assume that when x is equals to 0 first for the locus equation. So the locus equation is x squared plus y squared minus 6x minus 12y plus 20 equals 0. So when when y equals to 0, that's the x-intersect, x squared minus 6x plus 20 equals to 0. And we're going to apply the discriminant, b squared minus 4ac. So it's negative 6 squared minus 4 times 1 times 20. So it's equals to 36 minus 80, and it's negative 44, which is less than 0. Therefore, no roots. The locus P does not intersect the x-axis. Right. This is done. So question 7. Diagram 5 shows the straight line 11x minus y plus 4 equals 0 intersect the curve y equals to fx at point A. So the gradient function of the curve is 6x, so we have a gradient function here. So that is dy dx equals to 6x. Straight away I can write. So find the equation of the curve. So essentially, since I'm given the gradient function, I can integrate the gradient function to find the equation of the curve. So it's y equals to 6x squared over 2 plus c. Right, so to find the integration constant, I know one of the coordinates, which is here. So when x equals to 1, y equals to 15. So 15 equals to 6 divided by 2 is 3, 1 square plus c. So 15 minus 3 equals to c. C is 12. Therefore, the equation of the curve is y equals to 3x squared plus 12. Right, this is done for A. So for B, find the area of the shaded region. So I can use integration here again, but with limits. However, I need to be careful because this is my curve. Oh, that's not a good color. I should use yellow. So this is the curve, right? And I want to integrate up to this area here. So correct, if I integrate, I can find the whole thing here. But the shaded region is subtracting this other area here. So there is a trapezium in here, actually. Right? So I need to subtract the trapezium after. Right? So I will do the trapezium later. I'll just do the basic integration first. So my integration limits is from 0 to 1 because they gave a coordinate already. So by integrating, we are just going to integrate from 0 to 1, the curve equation, which is 3x squared plus 12 dx. And then we have 3x cubed over 3 plus 12x from 0 to 1. And to make it easier, just divide by 3. Right? So we have 1 power 3 plus 12 times 1 minus 0. So the area is 13 units square. So since we have 13 units square here, I can find the area of the trapezium. So the area of the trapezium, I'm just going to erase this part because this is not needed anymore. So the area of the trapezium here, if I were to extract it, it would look like this. Right? So to find out what this part is 0, of course. So now this part here, I can use the equation of the line 11x minus y plus 4 because this is an equation on the line here, right? Equals to 0. So this is actually the y-intercept. So I can say when x equals to 0, so 0 minus y plus 4 equals to 0 and y is equals to 4. So I know that this coordinate here is 4. This is solved. So I can find, I also know what is this point here. This one is actually referring to 15, which is up here. So I know that this from here to here is actually 15, right? And this one here is actually 1. So therefore the area of the trapezium is half times sum of parallel sides. You add the parallel sides together and you multiply the height, which is the base in this case. So it's half times 19 times 1, so it's 19 over 2. So that's about 9.5, right? Yeah. So from here, I can find that therefore the area of the shaded region is 13 minus 9.5, and that is 4.5 units square. Right, and this is done. So just gonna get rid of all this. Now, the volume of revolution in terms of pi, when the region bounded by the curve, the straight line y equals 17, and the y-axis is revolved through 360 about the y-axis. So we are gonna highlight what they told us. So we have the curve here. Y equals to 17 is kinda above A because A's coordinate is like 15, and bounded by the y-axis, which is this. So we are talking about this area here. Right, we are gonna revolve this thing. So in order to revolve this thing here, what we need to do is that first we need to consider what is our limits, right? So earlier on the equation, not the limits first. Let's consider the equation first. So the equation of the curve that we found earlier is y equals to 3x squared plus 12. Now the formula for finding volume is pi integral of x squared dy if you are talking in terms in respect to y, because they told us they want to rotate it about the y-axis, so we're going to have to rotate it like this. So we have to use y limits for this, so this formula comes to play. So we got to make x squared a subject in this case, so it will be y minus 12 equals to 3x squared, and x squared equals to y minus 12 over 3. Right? And now our limits, we need to know what this point here is, and we actually do because this is the y-intercept for the curve. So this is actually 12, which is here, and the one on top here we know is 17 because they told us this line is y equals 17. Right? So we have our limits as well. So when we write down, it's pi integral of 12 to 17, y minus 12 over 3 dy. And I'm going to just extract the 1 over 3 out of the integral just to make it easier to count. So it's 1 over 3 pi times y squared over 2 minus 12y from 17 to 12. So I'm just going to put it in here. So it's 1 over 3 pi. So it's 17 squared over 2 minus 12 times 17 minus 12 squared over 2 minus 12 times by 12. So most likely we are going to have to use a modulus function for this, because this area here is actually not underneath the graph. So it's actually on the other direction, because the curve looks something like this. So we are looking at a volume like this. This is actually not under the curve. Under the curve is technically supposed to be here, right? So the area that we get is going to be negative. So in order to change it to positive, we have to apply the modulus in this case, right? So long story short, if your answer you get is negative, for area, it should never be negative. So we should take it as a positive area, unless the question wants it that way, right? And that's a very specific way to, that's a very specific question, if they do ask you for it. So 17 squared divided by 2 minus 12 times 17, that is negative 59.5 minus, this is 144 divided by 2 minus 144, negative 72, and that's 1 over 3 pi, so it's 72 59.5, that is negative 12.5, and then divide that by 3, and don't forget the modulus. So this is going to be 25 over 6 pi units cube, right? And this is done for B2. It's a bit of lag for this. Ooh, did it crash? Yeah, kind of figured. Crashed. Right. So, where is it? Okay, I was here. Okay. So question 8a. So in a survey, it is found that the mass of the students in certain school are normally distributed with a mean of 40.5 kilograms and variance of 25 kilograms. So we have the mean, which is 40.5, and the variance, which is 25. So the standard deviation is 5 lah, basically, square root it. So a student is selected at random. Find the probability that the student has a mass between 36.2 and 45. So they are looking for this probability of 36.2 less than x less than 45, where we say x is the mass of the student lah. It can be any unknown actually, but I just prefer x in this case. So this is a normal distribution question. So because it's normally distributed, so from here we need to standardize our x values first. So we are gonna be using the z formula. So z is basically x minus mean over standard deviation. So that's why from here we take, for the first z, it is 36.2 over 36.2 minus 40.5 over 5, and that is negative 0.86. And the next one is z equals to 45 minus 40.5 over 5, and that is 0.9. So we got the two z-scores here already. So when we have the z-scores, we can have a sketch of the z-curve, the bell curve here. So I'm just going to draw a simple sketch here. So this is z. Now, positive values on the right side, so this is 0.9, and negative value on this side, which is negative 0.86. So the question is interested in finding what is the probability of students within this mass range, right? So we have to use the normal distribution curve to find out what, we have to use the z-score or the normal distribution table to sort of find out what is the probability for this and what's the probability for this. But when you use the table, it is always, the probability that you get is always towards the tail end. So in other words, because this is the halfway mark of the probability, this whole area here is 0.5. So we're going to take 0.5 minus the probability of z more than 0.9, which is this, in this direction. Right? When you apply the z-score, you always find towards the tail end. So we have to minus off this, and on the same on this side, this is 0.5 minus the probability of z less than negative 0.86. How I know this? Because it is going to the tail end as well, right? So I need to find this using my z-score. So I'm gonna go to my z-score. Where's my z-score? Is my z-score here? Yes, it is here. So what was it just now? Negative 0.86 and 0.9. Okay, so the way we use the z-score here is negative 0.86. Let me just write it down so I don't forget. And 0.9. So for negative 0.86, my z-score is going to be here, 0.8 and 6. So I'm going to refer to this here, right? So this is 0.1949. So the probability I get on the tail end is 0.1949, and the probability I get on the tail end for 0.9 is this. So 0.1841. Okay, right. So from here, I'm gonna go back here, right? So from here, we know that we're gonna take 0.5 minus, so this is negative 0.86, right? So that is, I think I wrote it down, 0.1949. So that is 0.3051, right? So this is the probability after minusing, and then for the other side it is 0.1841. So this is 0.5 minus 0.1841. So it's 0.3159. So therefore, the probability of the mass between 36.2 and 45 is 0.3051 added with 0.3159, and that is 0.621. Right? So this is part 1 done. So part 2, if the school consists of 750 students and 63 of them are undernourished, find the maximum mass of an undernourished student. So the probability of an undernourished student, in this case, I can use simple probability to just get a rough value, and that is 63 over 750. So this one gives me a simple probability of what an undernourished student will be like. So I get 0.084. Now, you can actually sketch the normal distribution curve from here already, because undernourished means you are less than the mean. Because here you're normal, here you're overnourished. There's no overnourished, we say healthy lah. So here is undernourished, means you're underweight, right? So they're looking for, what they gave us, is 0.084. So what we're interested is, the probability of 0.084 is probably somewhere around here, right? Because remember, the whole thing here is supposed to be 0.5. So 0.084 here makes the most sense because this part here is considerably larger, right? So since we know this, we need to find out what is the z-score that corresponds to 0.084. So we need to look back at our z-score table. So 0.084, so we're gonna look probably around here. Now I take this score because if you notice in the normal distribution table, in order to use the right side, it is a minus. So in order to get the value here, 0.084, I need to minus basically 13 at the back. So there is a value of 13 here. So the z-score that corresponds to this is basically 1.378. So that's the score I'm going to use. So 1.378. So that means the z-score here is 1.378, right? So now since I know the z-score already, I can work backwards with from this formula. So from here, I'm just going to erase the front part, don't need this anymore. So from here, I have z equals to x minus mean over standard deviation, 1.378. So I'm interested in looking for x now, because from here, I have x minus mean is 40.5. Standard deviation is 25. Standard deviation is supposed to be 5 in this case. So it is 5 times 1.378, which is 6.89 equals to x minus 40.5. So your x in this case would be 40.5 plus 6.89, sorry. So we get 47.39. Wait a minute, that's too big. Oh, sorry. This is a mistake here. Now z is not 1.378, it's actually negative because it's I forgot to say that it's actually on the left side of the curve. So it's negative 6.89 equals to x minus 40.5. So x is equals to 40.5 minus 6.89. So that is 33.61 kilograms. So this is the maximum mass for somebody that is undernourished in this case. Right? So for part B, don't need this anymore. So part B, we have the probability that Cairo scores a goal is in penalty kick is 0.8. So find the probability that Cairo scores all goals for 5 penalty kicks. So we can distribute this binomially. So in this case, scoring a penalty kick is a success. So P is 0.8. So the failure rate is 0.2, or it's 1 minus 0.8, which is 0.2. Because total probability when you add together, it must always be 1, right? It can't exceed 1. So the probability for him to score all 5 penalty kicks in 5 attempts, we are going to use the formula, which is NCR P power R Q power N minus R. So basically N is your number of trials, R is your number of successes, right? And you put it here, and N and P in this case is your success probability of success, and this is your probability of failure, right? So this is number of successes, right? Just to be a bit clear. So following the formula, we have 5 trials, 5 successes, probability of success is 0.8, power 5, probability of failure is 0.2, which is 5 minus 5. So from here, we just get 0.8 to the power of 5 lah, because 5c5 is 1, 0.2 power 0 is also 1. So 0.23277. This is probability. So part 2, the minimum number of penalty kicks required in order that the probability of scoring at least 1 goal is more than 0.9. So probability of x greater or equal to 1 is more than 0.9, right? I say greater or equal to 1 because it's at least 1, means it can be 1 or more, right? So in this case, how we're going to work with this is, instead of finding 1, 2, 3, 4, and 5, because we don't know how many attempts does he make, because they never gave us the n, so the n is actually unknown in this case. So in other words, we can do the complement for this by saying that this probability is equivalent to 1 minus the probability of scoring 0 goals. It should be greater than 0.9, right? Because don't forget, when we think about it probability wise, we have 0, 1, 2, 3, all the way until n. The question wants us to say what is this particular score here, right? We want to know we want to make sure that the probability in this case is greater than 0.9. So how many n does he need? So in other words, we know the total probability is supposed to be 1, so we are going to just erase this. We can take 1 minus this probability and we can find out this probability lah, right, in this case. So it's something similar to the sum formula that we have. So just going to erase this. So working with the formula, we have 1 minus, so it's NC, so 0, 0.8 to the power of 0, 0.2 to the power of n minus 0. So it is more than 0.9. So it's 1 minus, NC0 is 1, 0.8 power 0 is also 1, and 0.2 power n greater than 0.9. So in this case, just going to erase this. So we have 1 minus 0.2 power n is greater than 0.9. Negative 0.2 power n is greater than negative 0.1. By changing the symbols, I'm going to change the inequality symbol and I'll take log 10 on both sides. So I'm gonna, because I have unknown as my index, so by using the log law, I can move it to the front. And once again, I'm going to divide by a log that's less than 1, so it is actually a negative number. So it is n greater than log 10, 0.1 over log 10, 0.2. So that is n is greater than 1.43, therefore n equals to 2. So he needs to shoot a minimum of 2 kicks so that his probability is greater than 0.9. Right. Ah, crashed again. Great. So question number 9. Okay, so from here, now diagram 6 shows a semicircle PQS with center O, sector PRS with center P, given that the length of arc RS is 14.66, so OP is PQ, so this and this is the same. They did some sketching here already, so kind of a clue. So find the radius of the semicircle PQS. So we are looking for the semicircle of this here. Now, since we know that this is a semicircle, so that means this length is equivalent to this length, right? So we can actually take the entire sector here to solve. So that means we have SRS equals to R theta. So it is R is your R is unknown. So your theta is unknown also. Yes. So from here, if we look at it here, this particular part, this is the center of the circle. If we were to draw a line connecting to Q, we can actually create an equilateral triangle that looks like this. So this is 0, this is Q, and this is P. So if this is an equilateral triangle, means it is 60 degrees, 60 degrees, and 60 degrees. So our theta is actually this one here. So it is 60 times 3.142 over 180. We need to convert to radian to use the formula. So 14.66 here, and we can make R the subject. So before that, let's just count. So it's 14.66, so 60 times 3.142 divide 180. So it's 1.0473 R. So R is equals to 14.66 divided by 1.0473. So that is 13, basically 14 lah. 13.997 is basically 14 cm, right? So this is not the this is the R for the bigger one. So therefore, the R for the semicircle is 14 over 2, which is actually 7 cm, right? So this length here, we know it's 7 and 7 already, right? So this is A. So B, find the perimeter of the shaded region. So just gonna erase the inside here, just to sketch again. So the perimeter of the shaded region, we can simplify it into these few parts. We already know what this length is, right? And we know that this is the radius of the big sector. So we already counted it as 14 just now. So this part is 14. This one we know also. So the only two parts we need to find out is the one here and the one here, right? Or in other words, the semicircle, right? So the semicircle is very easy. So we can just calculate it as circumference in this case is C equals to 2 pi r. So in this case, it's a semicircle, so we take 2 pi r divided by 2. So it is just 3.142 multiplied with, the radius is 7. So we have 3.142 times 7, and that is 21.994 cm. So we can just add up everything. So the perimeter of shaded region is 21.994, which is the yellow one, plus 14.66 is given, and 14, which we have counted just now. So plus 14.66 plus 14. So that is 50.65 cm. Right. So part B done. So we look at part C, the area of the shaded region. So the area of the shaded region, we have to break down the area once again. So I'm going to split it into two parts. So I'm going to do this one first. I can find the area of this whole thing. Or maybe, yeah, sure. I can find the area of this whole thing. And then I just need to subtract this area and this area because it's a triangle. And then I can find the shaded region. So to find the entire area, which is the area of, this is PRS, this area of sector PRS, is just half r square theta. So half r is 14 square, your theta is 60 times 3.142 over 180. So just calculating that. So that is 102.639 cm square. So for B, B pula. For the next one, we have the area of sector QOS, this one here, right? So since we know this is equilateral triangle 60 degrees, we know the angle here is 120 degrees, right? Because it's a straight line. So it's just half r square theta again. So in this case, our r is 7 because it's the this length here is 7. So theta is 120 times 3.142 over 180. So again, so it's 51.319 cm square. Now finally the triangle here. So I'm just going to draw out the triangle to make it a bit clearer. So this triangle here, in order to find the area, I need to split it into half, because I need to know what is the height of the triangle, which is the thing I split into half, and this creates a right angle triangle for me. And I know that this is 7, and I know that this one is 30 degrees. So by using trigonometry, I can actually find out what the height is and what the base is, right? Or at least half of what the base is, this part here. So by using sine 30 is equal to opposite over hypotenuse, which is 7. So opposite here, I'm finding the base. So opposite is 7 sine 30, which is just 3.5 cm. Therefore, the base of the triangle is equals to 7 cm, because it's 3.5 times 2, right? So now the height of the triangle is cos 30, which is adjacent over hypotenuse. So it is just 7 cos 30. So this is the 6.062 cm. Therefore, the height of the triangle is equal to 6.062. So since I know this, then I can find the area of the triangle. So now the area of the triangle is equals to half times 7 times 6.062. So that is 21.217 cm square, right? So now I can minus all. So the area of the shaded region Q, R, and S is 102.639 minus 51.319 minus 21.217. 51.319 minus 20.217. So it's 30.103 cm square. Right, so we found out one region. So to find out the other region, we are now going to focus our attention onto the part here. So it's going to be here. So we already found the area of the triangle earlier, so we just need to take the sector minus the triangle. So the area of sector POQ is half r square theta. So it's half 7 square 60 degrees times 3.142 over 180. So it's 60 times 3.142 divided by 180. So it's 25.660 cm square. So the area of the triangle is 21.217. Therefore, the area of the shaded region PQ equals to 25.660 minus 21.217. So it's 4.443 cm square. Therefore, the area of the shaded region in total area of shaded region is 30.103 plus 4.443. So that is 34.546 cm square. Right, probably 55 if you want to round it out. So question 10. So question 10 shows a quadrilateral SVTX and triangle SUT. Straight line SU intersects straight line TV at point W, sure. So given that ST is 2A and SV is B, so TU equals to 3SV. So expressed in terms of A and B, SU and TV. So this information important. So ST is 2A. This one they already pre-labeled, but I'll just label over, I guess. So I want us to find what's SU. So to find for vectors is very easy. we take SU. Basically, how do we go from S to U in a very simple way? We can basically go from S to T and then T to U, right? And that is how we can do SU. So it's ST plus TU. ST is given as 2A and TU is given as 3SV given in the question, and we know that SV is equal to B. So it's just 2A plus 3B. Part 1, part 2. So TV in this case, I'll do it in blue lah, since I did that in red, just to avoid the color clash. So TV in this case would be, I want to go from T to V, so the most efficient way would be TS SV, right? So it would just be TS plus SV. So TS is just the reverse of ST, which is negative 2A, and SV is given as B. And this is done. Question 2 done. Okay. So next part, given that SW equals to HSU and TW equals to KTV, state SW in terms of HAB and KAB. Sure, so we can work with what they gave us, right? So I'm just going to copy down what they gave us, just the first part first. SW equals to HSU. This one answered my first question because this one got H. So SW, I'm not going to touch, but I know that SU earlier, previous question, SU I already count as this, so I can just put it in very fast. So it's just H2A plus 3B. Done. So part 2, in terms of KAB, so now I can use the other equation they gave. TW equals to KTV, right? Now TW is something that I'm not given, but when I look at the equation, TW basically is T to W here. In order to get there, we take TS and SW. We can use this root, right? So since we can use this root, I can rewrite it as TS plus SW equals to K, and TV I calculated earlier, I think, yeah, negative 2A plus B. So it's negative 2A plus B. So I'm going to make SW the subject, so SW equals to K, negative 2A plus B, and TS earlier is the reverse of ST, which is negative 2A. So it's minus negative 2A. So just going to multiply in so I can arrange properly, plus 2A plus KB. Okay, so I guess this one also I can multiply lah. So it's 2HA plus 3HB. Okay, so part 1 and part 2 is done. This is done, this is done. Now, they want us to find the value of H and K. So in order to find H and K, we have an equation for SW, 2 types already, so I can make them together. I can put them together. I can put this one and this one together. So 2HA plus 3HB equals to 2KA negative plus 2A plus KB. Now, because they are the same, I can equate their A vectors and B vectors separately. So this A vector and this A vector can be equated as 2HA equals to negative 2KA plus 2A. And I can drop all of the A. And I divide everything by 2. So I have a nice equation here with H and K in it. So and likewise, I'm going to equate the B. So it will be 3HB equals to KB, and I'm going to drop the B, so K equals to 3H. This is 2. So I can just say sub 2 into 1, and it will be H equals to negative 3H plus 1, 4H equals to 1, H equals to 1 over 4. And I can sub this back into 1. So H equals to negative K, or actually I sub into 2 easier lah. So 2, it will be K equals to 3 times 1 over 4. So K equals to 3 over 4. So this is my value for H and K. It's a bit hot. So to the last part, part C, if Sx is equals to 4 over 3a minus b, show that Su is parallel to xt. So I'm just going to write it down first. Sx equals to 4 over 3a minus b. Show that Su is parallel to xt. So I gotta write this down first. So Sx is basically, if I look back at the question, I can write it as Sx is equivalent to St plus Tx. Am I right? So I can rewrite this as St plus Tx equals to 4 over 3 A minus B. And I know St is A. Is it? 2A, is it? Yeah, St is 2A, sorry. Plus Tx equals to 4 over 3A minus B. And I can make Tx a subject. So it will be 4 over 3 minus 2. So it will be negative 2 over 3A minus B. Now from here, they want us to show SU is parallel to XT. So SU earlier on was 2A plus 3B. So I'm just going to put it here. So in order to show a vector is parallel to one another, I need to make an equation where I say SU equals to K Tx. Or we can sometimes they use lambda, right? The symbol lambda for wavelength. So from here, just going to erase this. I'm going to use lambda because they had K earlier, so it's just to avoid confusion. So SU equals to 2A plus 3B equals to lambda negative 2 over 3A minus B. So from here, I'm going to equate once again the A terms, but this time lambda is multiplied inside. So 2A equals to negative 2 over 3 lambda A. Drop the A, it will be 2 equals to negative 2 over 3 lambda. And lambda equals to oh, wait a minute. 4 over 3 minus 2 earlier. Did I count it? Oh, yeah. I did count it right, yeah. So in this case, lambda equals to negative 3. Right? So in other words, I'm now going to compare the B vector. So 3B equals to lambda negative B. So drop the B, it will just be 3 equals to negative lambda. Lambda equals to negative 3 once again. So since both lambdas are equals to negative 3, therefore we say that SU is parallel to XT. They must have the same value and symbol, so that we know that they are parallel to one another. Right, so 11, this is a graph drawing question, so I will not draw the graph, but I will help you guys to roughly solve the question. So they gave us an equation, y equal a to the power of y equals to bx squared. Right, from here. So we are supposed to plot a graph of y against log 10x. So y against log 10x means that y needs to be the subject and log 10x needs to be next to the gradient. So if I were to play with this equation, it would be log 10a power y equals to log 10 b power x power 2. So I can do the push forward. This one I can't push it forward because I need to split it into 2 first. So it'll be y log 10a equals to log 10b plus log 10x squared. So the square I can move it to the front. So now it's y log 10a equals to 2 log 10x plus log 10b. And to make y the subject, I divide everything by log 10a. So it's 2 over log 10a log 10x plus log 10b over log 10a. Now, I write it like this because I want to linearize the equation so it match the form of y equals to mx plus c. So this will be a straight line when you're done with it. So that's why when they give you x here, you can't just use the x here, you have to make all of it as the log 10 versions of themselves. So you need to log all of the x values here, the y you can retain the same. So end of the day, you'll get a straight line. Now, they say use the graph, right, to find the value of x when y equals to 9. So assuming that when you drew the graph, this is the graph of y against log 10x. This is a sample only. So if y equals to 9 means somewhere around here, so I can find a value for log 10x. So assuming that, let's say log 10x was 16. Now this is not the value of x, it is log 10x equals to 16. Means that I need to convert this back, I need to get rid of the log. So I can do the push-up rule for it, and okay, maybe not 16, but it's going to be very big, 1.6. So x equals to 10 to the power of 1.6. So I can find the value of x. But I must use my graph to do this, right? So you have to rely on your graph, but this one is just for me to let you know what to do. So they want you to find a and b as well. So to find a, you notice that a is inside your gradient. So if you find the gradient of the line here, you can equate it with this equation here. So in other words, usually when we find gradient, we try to take about 3 boxes apart here for higher accuracy, right? And usually they'll deduct marks if the triangle is too small, right? And this triangle needs to be drawn in dotted lines, right? And also again for the C here, part 2, the answer B, this is the y-intercept. So when you extrapolate the graph to the y-intercept, this is basically your C, right? And you're going to equate this with this, and then you can solve. Make sure to use the graph values. Do not just randomly key in values inside or just assume the values in this case. You cannot, by the way, you cannot use these coordinates as coordinates to count gradient. You cannot. You have to take other points. You will definitely get a even though you can use it, you're supposed to use it, but they want you to use something else, right? To test the accuracy of your graph line in that sense, right? So yeah, that will be it for question 11. So question 12, two particles A and B move along a straight line such that the displacement of the particles from a fixed point O is SM. Both particles start moving at the same time from O, where VA equals to, the velocity of A is 4t minus 3, and the displacement of B is 6t minus t squared, where t is time in seconds after the two particles start moving. A. Find the initial velocity in meter per second of particle A. So initial velocity is when t equals to 0. So we can just simply use VA equals to 4 times 0 minus 3, and we know that the particle is moving negative 3 meter per second to the left, right? Because negative, right? So part 2, what is the maximum displacement of particle B? So to find maximum displacement, what we are always looking for is that we are looking for when the velocity is 0. Means that when the particle stops moving, that's how far it's going to travel, right? Before it restarts its movement again. So we need to find a velocity equation for displacement. So for for motion in a straight line, we usually relate displacement, velocity, and acceleration with integration and differentiation, where displacement to velocity is differentiate, velocity to acceleration is differentiate the equation, acceleration to velocity is integrate, and velocity to displacement is integrate again. So now we want to go from displacement to velocity, so we need to differentiate the equation here. So we're going to differentiate this, so it will be dsb over dt equals to 6 minus 2t. So this I can write it as vb equals to 6 minus 2t. So when vb equals to 0, 0 equals to 6 minus 2t, so your time is equals to 3. So at the third second, the displacement of the particle is at its maximum. So since I know that, I'm just going to use this space here. Since I know that, I'm going to sub it back into my displacement equation. So 6t minus t squared, so t equals to 3, sb equals to 6 times 3 minus 3 squared, so sb equals to 9 meters. Right. So find the range of time of where both particles move in the same direction. So if you want to move in the same direction, it would mean that your velocity would have to be exactly the same. You have to have the same velocity, right, in that sense. So to have the same velocity, or at least the same manner of velocity, so from here we can say that, I'm just going to erase this space first, because I'm going to need it. So when I would like to correct myself, I shouldn't say the same velocity, but at least the same symbol of velocity. So I will take when VA is greater than 0 and when VB is greater than 0, right? So we need to know when these two velocities are in the same symbol, we know that they are traveling in the same direction. So since that, we have 4t minus 3 is greater than 0, and earlier on we have a velocity, we have a formula for velocity of B, which is 6 minus 2t. So 6 minus 2t is also greater than 0. So we solve for t, where 4t is greater than 3, t is greater than 3 over 4, and here is negative 2t is greater than 6, and t is less than 3. So we can make an inequality like this. We can combine inequalities like this, where this is 3 over 4 and 3, so it's in between this. So our range is between 3 and 3 over 4. This is the range of time that we need, right? So calculate the distance in meter that has been traveled by particle A and B when both particles met each other again. So that means they have met each other before. They want the particles to meet each other again. So it means that their displacement needs to be the same, right? That's when we know that they meet. So working from their displacement equation, we need to create a displacement equation for A. So Vt, 4t minus 3, we integrate both, so it will be Sa equals to 4t square over 2 minus 3t plus c. So when time is 0, they will started from origin, so Sa equals 0. So the displacement of A is 2 square minus 3t, very simply. So I can use this equation to work, so it will be 2t square minus 3t is equals to the 6t minus t square. So I'm gonna arrange this. 3t square minus 9t is equal to 0. So from here, I'm gonna solve for t. So I have t equals to 0, 3t equals 0, and t minus 3 equals 0. T is 0 and t is 3. Now, they said that they want to meet for the second time. So the first time they met was when time is 0, makes sense because they started from origin both. So the second time they met is at 3 seconds. So means that I need to find when I need to find the time in which the amount of distance that is traveled by particle A within that 3 seconds. So because I have the velocity equation for VA, right, I can actually integrate the equation once again, but this time I integrate it with my limits from 0 to 3, because I want to know how much distance did he travel between here and here, right? So since I integrate velocity to get displacement, if I put my limits in, I am finding the total distance traveled to actually the total distance traveled within that period of time. Because why is this the case is because if you look at the simple sketch, if I sketch a graph of V against T, right, and this is the graph like this, so you notice that the area under the graph represents the total distance traveled at this time, because according to the equation, velocity is distance, or in this case displacement, over time. So if I make distance a subject or displacement a subject, displacement equals to V times T. So V times T is basically the area under the curve. So this provides me the total distance traveled by that particle or object within a specific period of time. So integrating this would make sense, right? Because integration is area under the graph. So from here, I have 4t squared over 2 minus 3t from 0 to 3. So it's 2, 3 squared minus 3 times 3 minus 0. So in this case, it's 18 minus 9, and we have 9 meters here again. So distance traveled by particle A when when they meet each other again is 9 meters in this case. So question 13. So solution by skill drawing is accepted. I think they have done this question, but if I recall, I have seen the question before. The question didn't have that line in the middle, so the line is supposed to look something like this only. Yeah, somewhat like this. So sorry, it looks like a right angle triangle, but it's not. So this is 38 degrees. This is A, this is B, and this is C. So AB is 4 cm and BC is 4.9 cm, right? So they ask us to find the angle of ACB. So ACB is here. We need to find this angle. So in order to find this angle, we need to have at least one more length, right? Because we want to use either the sine rule or the cos rule. We can use the cos rule because the cos rule for these we do not know the angles, right? And this one we do not know the length. So we can actually use the cos rule because the cos rule states that c square equals to a square plus b square minus 2ab cos c. So the length corresponds to the angle. So we don't know the length, but we know the angle. Therefore, we can actually use the formula, the cos rule formula here. So it will be c square, or in this case is ac square, equals to ab square is 4 square, cb square is 4.9, minus 2, 4, 4.9, cos, so the angle is 38 here. So AC square equals to, so 16 plus 4.9 square, 40.01, and multiplying all this is 30.89. So AC square equals to 9.12, and AC will be equal to, square root it would be 3.02 cm. Right, so this is AC. So once we find AC, then we'll be able to use the sine rule. So the sine rule is basically I'll take AC over sine of angle ABC, which is equals to AB over the sine of angle ACB. So AC is 3.02, sine of ABC is sine 38, so AB is 4, sine of ABC I do not know, so I can count this. So 3.02 divided by sine 38, I have 4.9053 over 5 equals to 4 over sine angle ACB. So sine of angle ACB is 4 divided by 4.9053. So I'm going to just shift sign the answer after that, just to retain more accuracy. So it will be 54.63 degrees. So I found the first question, A here. So part B, point C prime lies on CB such that AC equals to AC prime. So sketch the triangle and state angle AC prime B. So when we do the sketch, this AC is supposed to be the same as AC prime, and it's supposed to be on this line somewhere, right? So very simply, I can just take this point here and I can do a rough sketch. Sorry, that's too thick. Connecting all the way here. So if I just to redraw the triangle, just for a bit of clarity. So from here to sketch, I'm gonna sketch from here till here, roughly, right? So I'm gonna say that this length here and this length here are the same, right? So if those two lengths are the same, means that AC is the same length earlier. So we found AC as 3.02. This is 3.02 as well, right? And the angles retain the same. So this is 54.63, right? And this is 4. Now, and this is 38. Now, they said what is the angle of AC prime B? So this is A, C prime, and this is B. So because these two are the same length, they are isosceles triangle now. So this is also 54.63, and we can find the angle AC prime B easily by taking 180 minus 54.63. So we can find this here. So it will just be 180 minus 54.63, and that is 125.37. Right. So 125.37 degrees. So find the area of the triangle AC prime B. So AC prime B, in this case, we find the area of the triangle. So just to do another rough sketch of the triangle, right? Because I can't really like erase, because I'm just going to erase the whole thing, so I may just redraw. So C prime B. So this is 38, this is 3.02, and this is 4. Now, if I want to use the formula half AB sine C, if I want to use the angle here, I must use a length here, or I must use the length here and here, right? So I have to be a bit selective with the angle that I use. So since I'm given this length and this length, I can technically use this angle here, right? Because I'm not using the length here, and I do not know what it is either. So I can find this angle because I know what this angle was. It was 125.37. So the angle C, so when I use the formula, it will be half AB times AC prime using the angle of sine C prime AB. I want to use this angle here. So it will be half AB is 4, AC prime is 3.02, and sine of CA prime B is 180 minus 125.37 minus 38. So it's 16.63 degrees. So just to put a note here, 180 minus 125.37 minus 38, and that is 16.63 degrees. So just multiplying this, so 4 times 3.02 times sine 16.63 divided by 2. So it's 1.729 cm square, or 73 lah, cm square. Pretty close, right? So that's done. So find the shortest length in cm from C prime to the straight line AB. So the shortest length always refers to the perpendicular distance. So when I want to talk about perpendicular distance, I'm looking from here till about here, right? So I'm actually creating a right angle triangle here, where this is A, C prime B, and this is the B earlier lah. So I already know this length 3.02, and I know this angle that I found just now, which is 16.63. So since I have this, I can just use trigonometry to find out what this length is. So it'll be sine 16.63 equals to opposite over 3.02. Better change color, it's a bit light. So opposite is equals to 3.02 times sine 16.63. Oops. So this will give me 0.864 cm. Right, so that is the shortest length in cm. So question 14. Table 3 shows the price indices for and percentages of usage for 4 items which are needed to make a type of handicraft. Sure. So a lot of unknowns. So calculate the price item S in the year 2017 if its price in the year 2019 is 57.2. So price index formula is standardized as P0 over Pi, or sorry, is it P1 over P0 times 100. This will give us price index. Right, P1 is our year, the year that we won, and P0 is the year of reference. So in this case, they gave us P of 2019 over P of 2017 times 100 for the object of S. So they already gave us the price index, which is 104, right? So the price in 2019 is 57 ringgit and 20 cents, and the price in 2017 I don't know. So dividing 100 on both sides, this becomes 1.04. So by making P 2017 subject is 57.2 over 1.04, and that would just give us 55 ringgit. So part B, the price index of the item Q in the year 2017 based on the year 2015 is 110. So I'm just going to write that down. So P 2017 over P 2015 for Q is given as 4x. So times 100 equals to 110. Okay, I'm just going to write this first. So calculate the price index in terms of x of the item Q in the year 2019 based on 2015. So here I need to use a bit of a chain rule. So 2019, 2015 means that 2019 needs to be on top, 2015 needs to be on the bottom. And the year that connects them together is 2017, right? Because these two can cancel out, right? So P 2019, P 2017 is given in the question as 4x, and 2017, 2015 is given here as 110. Right, so we're going to divide this by 100 because the value is going to be very big if we don't. So it will be 4.4x here. So some students ask me, what's the difference between dividing 100 and times 100? See, cutting the story short, you divide by 100 when the value is too big, you multiply by 100 if the value is too small, right? So you'll be able to reach it in the end, right? That's just a simple way of understanding it. So from here, we have part C. So the composite index for handicraft production on the year 2019 based on the year 2017 is 116.6. So we know P 2019, P 2017 equals to 116.6. They ask us to find X and Y. So we can count the price index based on what we have here, because the formula for composite index is summation IW over summation W. Means you add the index times the weightage divided by the total weightage. So from here we can do 120 times y plus 4x times 20 plus 130 times x plus 104 times 40. So the whole thing is going to divide by y plus 20 plus x plus 40, and this is going to be equal to what they gave here, 116.6. There's not enough space here, so I'm just going to calculate it as quickly as I can. So this will be 120y plus 80x plus 130x plus 4160 over x plus y plus 60 equals to 116.6. So I'm going to cross multiply, so it will be 120y plus 210x plus 4160, 116.6x, 116.6y plus 6996. So I'm just going to put all the x and y's together. I'm just going to move everything, all the x and y's to the left side and the numbers to the right side. So 120 minus 116.6 is 3.4y. 210 minus 116.6 is 93.4x. And 6996 divided by 4160, sorry, minus 4160 is 2836. Right? So I can call this one equation here. So with this equation here, I can actually create another equation because I have two unknowns, which is the sum of percentages should be 100%. So y plus 20 plus x plus 40 should be equals to 100. So y is equals to 100 minus 60 minus x, which is supposed to be 40 minus x. So I can sub this, I can sub 2 into 1. So 3.4 times 40 minus x equal plus 93.4 x equals to 2836. So 3.4 times 40 is 136. 3.4x plus 93.4x equals to 2836. So from here, just gonna erase this. So it will be 90x equals to 2836 minus 136. So that is 2700. So x is equals to 30. So since I know x is 30, can find y by subbing it back to 2. So it will be y equals to 40 minus 30. So that will be 10. So x is 30, y is 10. So now the cost for all items increased from the year 2017 to the year 2018 by 10%. So find the composite index for 2019 based on 2018. So again, chain rule, 2019, 2018 equals to 2019 here, 2018 here. So the connecting year will be 2017. So I know the composite index for 2019, 2017, they gave it to us here, which is 116.6. And 2018, 2017, they actually gave it to me here, right? They say all the price increased by 10%. So basically, P 2018 over P 2017 should just be 110 because 100 is always the baseline. If you increase by 10% means it's plus 10. If you minus 10, if you decrease by 10%, you minus 10, and so on and so forth. So this is P 2017 over P 2018. So since P 2018 over 2017 is like this, so it's going to get inversed. So like I mentioned earlier, this is going to be a very small number, so I'm going to multiply by 100 just to standardize the number here. So the answer is 106. Done. So that is it for 14. So last question, 15. Again, this is a graph question, so I will not be drawing the graph, but I'll be showing you how to solve. So enrollment of students, so this is a course at math, the number of students, x and y, and fee per subject. So we have three constraints. Maximum number of students is 400. Max number of students taking at math does not exceed number of students taking math in ratio 5:3. Total fees collected for both subjects is at least 5,000. So questions ask us to write the three inequalities which satisfy all the above coordinate constraints. So maximum number of students is 400. So this is very simply x plus y must be less than equals to 400 because this is the maximum. You can't pass 400. So that's why this is the first inequality. Second inequality, number of students taking additional maths does not exceed math in ratio 5:3. So in other words, at math ratio math is 5:3. So if I change it in terms of fraction, it's 5/3 equals to, in this case, is x ratio y. So I can put x over y here. So when I cross multiply, it's 5y equals to 3x, right? So we must pay attention to what is what. X refers to the at math. So at math does not exceed math. Means that we are trying to say at math students is, they are actually more mod math students than at math students in this case, right? So we can simply write it as 5y greater than 3x. So this is how we make sure it does not exceed, greater equals to lah, right? So it can be equal to, but it doesn't exceed. So we can write it like this. So for the third condition, total fees collected for both subjects is 5,000. So x times 70, 70x, y times 50, 50y, and it must be at least 5k. So it's greater equals to 5,000. So once you have done with the inequalities, we can sketch these three lines on the graph. So very simply, just take any two coordinates on the line and then you can make the line very easily. The most important thing is that if we have to pay attention to the symbol. So the symbol, if it's more than equal to, we are going to be using solid lines to draw. So according to the answer, the solution looks something like this. Yeah. Okay, and the answer is supposed to be here, this shaded region here, right? So the way we read it is because oh sorry, this is actually for part 2. So C1, based on the graph, what is the maximum fees and the minimum total of enrollment? So maximum fees, basically, we are referring to how we plot it in the first place. So when we plot this and this, what we are looking at is, we are looking at the the y-axis is actually what? Y-axis is... they didn't tell us. So y-axis, I'm just going to assume that it is cost lah, right? Money. Wait, no. Y-axis should refer to the mod math students. Sorry, mod math. This is y. And x-axis should refer to the add math students. So the maximum cost in this case would be around here. I can't take this because I'm losing out on MF students. So this is the optimal amount of cost for both the add math and mod math students. So I'm gonna take this coordinate here to count for the maximum amount of money. And when they talk about minimum enrollment, means which is the lowest amount of students. So minimum enrollment will be here. So this will refer to minimum enrollment. And this will refer to this coordinate will refer to the maximum fees. Maximum fees. Right. Don't forget that the fees formula is still like this, 70x plus 5y. So you're gonna have to substitute the x and y into here and count the value. Same thing goes for the minimum enrollment. Right, you're gonna have to add the x and y because this graph is mod math against add math student in this case. So that is all for the MRSM paper 2 2020. So if there are any questions, please don't hesitate to ask me in the comments or message me, email me. So all the information is down below in the description. So if you would like me to cover any type of paper or you want me to explain another question in greater detail if I didn't explain well enough here, you can always message me, email me, and I will prepare a video for that. So with that, I will call it off for today, and thank you for watching the video. I hope this will be helpful for you.